Thank you everyone for taking the time to join me today to discuss turboblower RPM speed control and how REXA actuators can improve the performance at your plant. My name is Mark Farah. I handle the metals and mining industry for REXA, and I am pleased to have the opportunity to introduce our technology to you. The past 2 years have witnessed a recovery of steel production in North America. Idle plants have restarted, or idle plant blast furnace have been brought back online. The industry is enjoying healthy steel product demand, and plants are operating at over 90% capacity utilization. For this reason, this webinar is focused on the air feed of blast furnaces. For some of you attending, you may have experience with our product, so parts of this presentation will be a nice refresher. For those new and looking to gain a better understanding of electrolytic technology, I'm confident you will find the webinar to be informative and gain valuable insight on REXA. For the webinar agenda, the topics we'll be going over include: what is an actuator? The retrofit at U.S. Steel Gary Works on the turboblower speed control, actuator types and electrolytic technology. To better understand the REXA technology, we need to look at other types of actuation to distinguish them from our product capabilities. It was from the need to combine the benefits of each type of actuation technology that REXA originates and eventually took shape. We'll also look at the inner workings of the REXA actuator and what makes us the most unique actuator technology on the market. Applications. In order for a mill to operate efficiently and in a safe condition, it is important that the turboblower operate with minimal unscheduled downtime. We'll touch on some of the other cold blast control applications where REXA can be used. You'll see some REXA installs and blower applications, and we'll talk about how they improve plant performance and efficiency. We'll wrap up the application discussion portion of the webinar with some important takeaways. And finally, we'll give a brief company overview of REXA and answer a few questions. Please be sure to share your thoughts throughout the webinar. Let's get started by defining what an actuator is. The simple definition of an actuator is a pneumatic, hydraulic, or electrically powered device that supplies force and motion to open and close a valve or damper. I will now relate the functionality of an actuator to the human body. We begin by looking at a simple automated valve actuator. When the brain or controller communicates via nerves or transmitters, the body's sensors, such as the eyes or the nose, detect environment conditions. When the controller determines the appropriate correction signal, the actuator is the required muscle to position the valve. In terms of responding to the correction signal, controllers do not control. They make decisions and send commands to the final control element. Sensors do not control, they sense. They see, feel, or measure pressure or temperature in the process. Control valves do not control, they simply act as an adjustable orifice in a pipe. Actuators are the final control element that physically makes these adjustments. They are the muscles of the process plant. In the current state of actuation, pneumatic actuators are soft and pushed around. Their speed is slow and their sizes can be very large. The diet for electricity is large, continuously consuming power and air. Finally, they can't get comfortable and stable, continuously twitching due to stick-slip movements. What we are interested to achieve in state-of-the-art actuation is stiff or rock-hard positioning and cannot be pushed around, must be quick and accurate when the control signal changes, be able to run efficiently with low power consumption, that is, live on a low-calorie diet. Finally, we must be smart so that positioning can be configurable with detailed diagnostics of system or body health. So let's begin the discussion on the turboblower control with some details about steelmaking process, which is complex and involves several important operations. Today, our focus will be the blast furnaces used at integrated mills. Note how the blast furnace has several downstream customers at the basic oxygen furnace, refining, and casting. Process interruptions of the blast furnace will impact the steel production of the mill. Let's take a quick look at what is happening chemically in the blast furnace. A blast furnace is top charged with iron ore, coke, and limestone. Huge quantities of air blast enter the bottom of the furnace. The oxygen in the air first reacts with coke to produce carbon monoxide. The carbon monoxide reacts with the iron ore in a reduction reaction. The products leaving the bottom of the blast furnace are molten slag and iron. The gases carbon monoxide, carbon dioxide, and nitrogen leave the top of the furnace. This is a continuous process, and unscheduled downtime is costly for an integrated mill if the supply of molten pig iron is disrupted. To create 1 ton of pig iron, 5 tons of air is consumed. The blower supplies the blast furnace with sufficient oxygen needed to complete the reduction reactions to make hot metal or pig iron. The air blower is also required to have sufficient pressure to lift the burden in the furnace. Variation in feed amounts and quality can impact air demand. Air blowers need to have a very high level of reliability since the performance of the blast furnace depends a lot on the performance of the blower. On this slide, we will examine only the turbo blower speed control application. For a blower speed control, an actuator moves the power piston in a linear motion, opening and closing the steam emission valves that controls the amount of steam into the turbine. The more steam into the turbine, the more air the blower provides to the blast furnace. The gas pressure is key to lifting and maintaining the molten burden height as it is converted. The consequence of poor reliability can be severe for the mill. Failure of the actuator could result in a loss of gas pressure in the furnace, resulting in burden dropping and damaging the lower section blowpipes and tie-ores. The internal temperature at the center of the furnace is over 1900 degrees Celsius. Cooled burden can harden and is very labor-intensive to repair. In fact, a jackhammer is needed to break up the cooled metal. Production is impacted and the mill loses revenue. In some cases, as much as $1,500 per minute on a mid-sized blast furnace if the plant end product is hot rolled steel. In 2018, at the U.S. Steel Mill at Gary Works, the existing electrohydraulic actuator was a problem for the plant. Maintenance issues relating to oil fouling and leaks were reoccurring. The OEM service was repairing and servicing the unit every 3 to 4 months at a cost of nearly $4,000 per visit. Parts availability due to old age were also not readily available. Sticky response to position change after long durations was causing speed variation from set point turbine RPM speed. So in 2018, the electrohydraulic actuator was quickly and easily retrofitted with the Rexa linear actuator. Please note the Rexa can be mounted at any orientation because the oil is sealed from the outside environment. The new Rexa has sufficient thrust with 5,000 pounds force and fast speed at 1.25 seconds per inch. The loss of power position is fail in place. Redundant power modules improve reliability. For example, if the motor were to stop working, the unit will continue to operate at 2.5 seconds per inch speed, and the force output would remain unchanged. It has quick change connections for fast power module swap out. Oil-based maintenance is eliminated, and it has excellent repeatability, and the typical maintenance interview is 5 to 10 years. Let us now step back and discuss the 3 types of actuator technologies that can be used: pneumatically driven, mechanically driven, and hydraulically driven. Each uses a different method to develop forces and create motion, all with advantages and disadvantages. First, pneumatic actuators are most common on control valves on new equipment and projects. Their advantages include low purchase price and they have fast stroking speeds. However, there are limitations of using pneumatics. Because air is a compressible fluid medium, it needs to build up in order to create motion. The results are losses in resolution, overshoot or undershoot, and increased dead time. Even with the use of a smart positioner, the compressibility of air is an inherent problem to achieve rapid and accurate positioning. Operating costs are expensive when you include air compressor energy, dust filters, and water separators. In cold weather, moisture in the air lines will freeze and make the pneumatic actuator non-functional. This graph shows the positioning performance of a Rexo actuator versus a pneumatic actuator. The changes to the black line control signal are easily followed by the Rexa in green. But with the pneumatic in red, it cannot respond fast enough and often overshoots or is unresponsive to the desired set point. With a deadband at 0.1%, which leads to a resolution of less than 0.1% and a linearity correctable to 0.05%, the Rexa X-Pack is the only actuator product line truly capable of matching the potential of modern control systems. Next is electromechanical actuation, most commonly found on on-off type service, which provides tighter control and better frequency response than pneumatic actuators, but not hydraulics. Electromechanical actuators are also good for outdoor service. However, most electromechanical actuators can have limited duty cycle, limited force or torque output, and limited fail-safe options. Electromechanical actuators wear from gears contacting one another. The result is over time, hysteresis will increase and the valve movement will be different from the control signal. The use of linkages will further increase this effect. The use of electrohydraulic actuators are common to critical control valves at the blast furnace. These systems provide high frequency response and great accuracy with the high duty cycle. They're also good for high torque applications. These benefits, though, come at a cost. High capital cost, electrical consumption, and maintenance costs add up to offset the positioning benefits. This is an example of an HPU skid controlling 3 valves for cold blast air. HPU units typically have large oil volumes that need routine oil maintenance. Since the hydraulic systems are open looped, the oil in the reservoir has contact with the environment. Over 80% of hydraulic actuator failures are the result of contaminated oil. Water, oxygen, and air and particulates are examples of foreign matter that degrade the oil quality over time. For example, acid numbers increase every month. Components like servo valves are very sensitive to changes in hydraulic fluid quality. A complex preventative maintenance PM schedule is needed to maintain the hydraulic fluid's optimal properties. Oil sampling, oil maintenance, oil flushing, and replacement must be done regularly to reduce unscheduled failures. Failure of a key HPU part may disable multiple valves. Rexa combines the benefits and capabilities of each of the actuator technologies into one: the simplicity and high-duty cycle of pneumatics, intermittent operation of electromechanical, and the positioning accuracy and fast actuation speeds of hydraulics. So let's talk about some benefits of the electrolytic actuator. To start with, it's a very unique design, unlike anything on the market today. The true closed-loop hydraulic system is closed to the ambient environment, with oil volumes approximately 90% less than those found in a standard HPU skid. Smaller Rexa units have as little as 400 milliliters of oil, which is less than a can of Coke soda. There are no filters or oil changes required, making it maintenance friendly. All models can operate at 100% duty cycle if required. These units are accurate and repeatable to less than 0.1% of span. Our modular design allows for very high thrust and torque outputs with high speed fail-safe options. Having Rexa actuators installed at major steel producers around the world, Rexa actuators are unmatched when it comes to being rugged and reliable. The electrolytic technology consists of 2 primary components: the mechanical subassembly and the electrical subassembly. The mechanical portion is attached to the driven device, which in the case of a turbo blower speed control is the power piston. It contains the motor, pump, flow match valve assembly, cylinder, and feedback housing. The electrical subassembly is basically the positioner for the actuator. This is where the main power supply and control signal are routed, and the origination of 4 to 20 milliamp feedback position for connection to the DCS or other control system. Digital communications such as HART or Foundation Field Bus are also available. We separate the electric and mechanical assemblies for ease of access and operation. There are many severe applications, for example, very close to furnaces where onboard electronics simply would not survive. The control box can be mounted to a convenient location next to the valve or up to 700 feet away. The mechanical subassembly, with rugged and reliable construction, is able to operate in ambient temperatures between -40 Fahrenheit and 250 Fahrenheit. Let's look closer at the REXA hydraulic circuit. This is the real area of differentiation with our technology in comparison to HBU-based electrohydraulic systems. The centerpiece of the electrolytic circuit is our bidirectional gear pump, which is coupled to the REXA brushless motor. The gear pump works in conjunction with the flow match valves, which are designated as FMV1 and FMV2 on the schematic. It is important to note from a size perspective, the flow match valve and the gear pump can each be held in the palm of your hand. During operation, at the desired position, spring-loaded ball checks are locked in place to prevent the flow of oil through the flow match valves. The cylinder is hydraulically locked into place, so forces acting on the valve will not result in valve movement, which is observed in pneumatic actuators. But when there is a signal change, the motor activates, turning the bidirectional gear pump, which instantaneously builds pressure, allowing the ball checks to open. The oil is then transferred through the flow match valve from one side of the cylinder to the other. Once the actuator has reached its desired set point, the motor stops, the ball checks are seated, stopping the flow of oil through the system. When in standby mode, power draw in the electronics cabinet is only about 70 watts. The motors are designed for 100% duty cycle if needed and capable of very high frequency response from 1 to 5 hertz. The cylinders that we use are dual rod or rack and pinion, so the oil volume exiting one side of the cylinder is equal to the volume entering the other side. This design eliminates both the requirement for an external reservoir and the need for continuously circulating oil through the system. This also leads us to another significant benefit of our technology, greatly reduced oil volumes. So now we can return to the blast furnace cold air system and discuss some of the applications where REXA can be used. We previously discussed the steam governor speed control. The inlet guide vanes on an axial blower adjust the air into the blower to control the blower mass flow or discharge pressure to the stoves. For number 3, the anti-surge control valves modulate to vent air and avoid surge conditions. For the turbo blower application, the anti-surge valves act as vent valves to prevent the turbo blower going into surge by reducing pressure from the discharge side. For number 4, the blow-off valves allow for rapid venting of air to avoid surge conditions. Finally, the snort valve is opened when it is necessary to decrease the blast pressure rapidly. This discharges the cold blast air to the atmosphere and keeps a positive pressure on the cold blast line so the gas from the furnace cannot travel back to the air blower. For anti-surge, key actuator parameters are be fast acting. REXA has a dead time of less than 100 milliseconds. It can open and close the valve in less than 2 seconds. The resolution is adjustable to 0.1%, and the frequency response is 4 to 5 hertz. We'll now briefly show a few REXA installs in these or similar steam turbine applications. This slide is Tata Steel in India, 15,000 pounds force of thrust, retract open on loss of power, and this was commissioned in 2007. This is an example of a blow-off valve application. This is JSW in India. After commissioning, it went 18 years in operation with $0 spent on maintenance, and the blow-off valve was opened on loss of power. This is an example of a IG inlet guide vane airflow control. This is at BHP in Australia. This is controlling airflow into the compressor. This is an example of a steam compressor main air at a refinery where after putting on the Rexa, this allowed the plant to manage better process disturbances, improved throughput due to less time and recycle, increased process uptime through elimination of trip events. Speed swings went from 300 to 2 RPM. Just with these improvements to the compressor, the net impact to Western Refining was over $11 million. That's an excellent return on investment. So the takeaways from the use of Rexa electrolytic actuators on blast furnace turbo blowers are the following. Meet the high performance capabilities of hydraulic control when operating as intended. Eliminate complex hydraulic power units to reduce actuator maintenance. Eliminate problems from oil cleanliness. Avoid particulate problems in sticking with servo proportional valves. Realize performance gains in compressors and fans. Optimize control with less than 0.1% repeatability. High frequency response with no overshoot. And extend time between maintenance cycles and maximize system availability with redundancy. A bit about Rexa for those unfamiliar. The unique actuator patented concept and company began as a small startup in the early 80s. After trial and error, the first generation model was installed in multiple industries in 2001. In 2008, the X2 generation contained key features that built upon the core technology to make it rugged and reliable. In 2016, the X3 electronic module added additional diagnostics and ease of maintenance. Rexa's rapid and consistent growth continues with over 39,000 actuators and drive units sold worldwide. Rexa headquarters is near Boston, Massachusetts, and a service and distribution center is in Houston, Texas. Rexa continues to expand and grow, focusing in key industries such as metal and mining, power, and oil and gas. Rexa is an established partner with the major steel producers around the world. Whether it is an integrated or mini mill, Rexa can solve the toughest steelmaking applications.